Our last topic in differential equations is determining initial conditions. So here's the solution from the previous discussion that we had in the last video. And let's say that I know at t equals 0 that y of 0 is equal to 1/4, and my derivative at 0 is equal to 2. Now notice that I'm using the same time value, in this case t equals 0, and it's very common to use t equals 0 because things simplify very quickly. Normally the two times would be at the same instant, but they don't have to be, but I'd say 99% of the time that they are. So you would do, if you wanted to do t equals 1, you do it for both of these. Now I can put in the 1/4 with this equation and put 0 in for t's. So I would get y of 0 equals c1 cosine 2 times 0 plus c2 sine 2 times 0 minus 3/4 times 0 cosine of 2 times 0. And that would equal 1/4. Well, cosine of 0 is 1, so I have c1. Sine of 0 is 0, so this term's going to cancel. And this last term's going to cancel, so I get c1 equals 1/4. Now I need to take the derivative of my solution, and I've already taken that derivative, so I'm going to let you do this on your time. Let me just show the derivative before I put the 0 in. So my derivative is going to be negative 2c1 sine 2t plus 2c2 cosine 2t minus 3/4 cosine 2t plus 3/2 t sine of 2t. Like I said, I'm going to leave you to do this on your own. Just take the derivative of the solution. And now I can put in my 0 for t. And that's going to be equal to 2. First term, sine of 0, this is going to go away. Second term, cosine of 0 is 1, so I have 2c, 2c2. The next term, cosine of 0 is 1, so I'm going to have minus 3/4. And the last term is going to cancel out, and this is going to be equal to 2. If I solve this, C2 will be 11/8. So our solution with initial conditions is equal to 1/4 cosine 2t plus 11/8 sine of 2t minus 3/4 t cosine 2t. If we had different initial conditions, we would have different coefficients for C1 and C2. So this only applies to these initial conditions.